Let's see if today goes any better. So our last section of the week is 9.3, which is geometric sequences in series. So as you could guess, maybe a geometric sequence is a sequence where your ratio, where you have a sub 2 divided by a sub 1 is the same as a sub 3 divided by a sub 2, etc., which we call R. R clearly can't be 0. R is called the common ratio. All right? So just like yesterday's assignment, but now we're dealing with multiplying. So for number 1, really straightforward, find the common ratio of the following geometric sequences. So we don't have to check that they're all the same because you're told that it's already a geometric sequence. We just have to find R. So pick your favorite 2. So I'll take 6 and divide by 3. So R is 2. That's it. Using purple and blue was not the best choice here, but oh well. All right, so for B, same deal. I'm going to do 1/2 divided by 1. So my R is 1/2. Done. Easy as that. Okay, moving on to our proofs, just like I showed yesterday. So a proof for the nth term of a geometric sequence. So again, we know that a sub 1 is equal to itself. A sub 2 in terms of a geometric sequence would be a sub 1 times that common ratio R. A sub 3 would be a sub 2, come on and focus, times R. But again, we're doing a proof to show you the derivation of an equation here. This thing would just work with me. Okay, so a sub 2 we know is a sub 1 times R, so making that substitution in. Another way to think of a sub 3 is really a sub 1 times R squared. A sub 4 would be a sub 3 times R. We know a sub 3, another way to write that is just a sub 1 times R squared. Multiply your R's. Another way to think of a sub 4 is a sub 1 times R cubed. So looking at your pattern, therefore we can say if you have an a sub n, that's equal to your first term a sub 1 times R to the power of n minus 1, which you should see there. So that's an important equation you will see us using here. All right, moving right along. So number 2, find the nth term for the geometric sequence with the first term 5 and the common ratio of 2. So using the little equation there we derived on the other side, we're looking for a sub n. Again, this one's just as straightforward as number 2 from yesterday. Your first term is 5, so that's your a sub 1, and your common ratio is 2, so it's 2 to the n minus 1. And that's your answer. That one's pretty straightforward, just like yesterday. Number 3, find the 20th term. This thing would just clue in here, of the geometric sequence 1, 3, 9, 27, etc. Again, we wouldn't be looking for you to actually do it out to the 20th. We'd be looking for you to show the use of the equations for this. So you'd stop and you say, all right, I already know it's a geometric sequence, so I should find my R. So 3 divided by 1 is 3. So a sub 20. So I take my first term, which is 1. And then I take my R, which is 3, and I raise it to the n minus 1. In this case, n is 20, so it's to the 19th. And you will get this number here. Let me write it. So you'll get 1,162,261,467. Boy. Great. Moving right along. Let's see how many interruptions I get today. Number 4, find the 15th term of the geometric sequence with a third term. So I'm going to write that down for myself. A sub 3 is 5/4, and 6th term, so a sub 6 is 5/32. So just like yesterday, I'll show you 2 different ways that you can go about doing this anytime. Just, you gotta love it. All right, so doing kind of the system approach that I showed yesterday. Here we go. A sub 3, I can think of that as a sub 1 times R squared. All right, and so we know that that's 5/4. A sub 6 we can think of that as a sub 1 times r to the 5th, and we know that's 5 over 32. So thinking of this here as your system, we can solve that to find r. So I would solve each of these for a sub 1, and hopefully you can agree from this one I would have a sub 1 equals 5 over 4r squared, and this one would give me a sub 1 equals 5 over 32r to the 5th. Okay, so putting these together by substitution, I would have 5 over 4r squared equals 5 over 32r to the 5th. I'm going to choose to multiply everything by r to the 5th, a couple different ways you could do it. But this on the left will leave me with what? 5r cubed over 4 equals 5 over 32. Okay, you can multiply your extremes there. Let's see, and so we should get 160r cubed equals 20. I'll get r cubed equals 20 divided by 160, which is just 1/8. Take the cube root of 1/8. R is going to be 1/2. All right, so that's great. Now I need to find, though, my a sub 1. So I'm just going to substitute back into any equation. This thing would become blurry. Any of these equations here, right? I'm just going to go with that one. I could have done that, but oh well. So I have a sub 1 is 1/2 squared equals 5/4. So I'm really doing 5/4 times 4 over 1. So a sub 1 is 5. So my equation for this, putting everything together here of what I have, I love all my scrap paper here, use what you have, a sub n is your a sub 1, which is 5, times our r, which is 1/2 to the n minus 1. So back to the question, it says what's the 15th term? So a sub 15 will be 5 times 1/2 to the 14th. And if you do that out, please don't write it as a decimal, please keep it as a fraction. You should get 5 over 16,384. So there's one way to do it. And oh, look at this. I left myself tons of room to do the other way. We'll make it work. So that's one way. I'll go through the other way like yesterday. So I'm going to write it in terms of a sub 6. Okay, and that's the same as a sub 3 times r to the 3rd, because it would take 3 r's to get from a sub 3 to a sub 6. So we know a sub 6 is 5 over 32, and a sub 3 is 5/4. So again, you're going to get much more direct, many of you might think. R cubed is 1/8 once you simplify that. Take the cube root, so r is 1/2. All right, and again, through the same thing here, we know a sub 3 is a sub 1 times r squared. So I would have 5/4 equals a sub 1 times 1/2 squared. And once again, you'll get a sub 1 is 5. And then it would be the same thing from what I did down here to get your a sub 15. Okay, where am I? Sorry, wrong side. All right, so now for a similar proof of what I did yesterday for the sum of a finite geometric sequence, also referred to as an nth partial sum of a finite geometric sequence. So we talked about yesterday how S sub n would be the summation of the first n terms. So a sub 1 plus a sub 2 plus a sub 3 all the way up to a sub n. Just like yesterday, I could rewrite this now in terms of all a sub 1s. So a sub 1 would stay the same. A sub 2, we can rewrite that as a sub 1 times r. A sub 3, we can rewrite that as a sub 1 times r squared, all the way up to a sub n, which would be a sub 1 times r to the power of n minus 1. I'm going to have that boxed in because I'm going to use it in a minute. We might not think to do this, but this actually helps us with the proof. We can take this equation here, and again, wouldn't think to do it, but you would agree with me that it is true. I could multiply the whole S sub n equation by r. You're like, why would you do that? Well, just hold the phone and you'll see in a minute. So if I multiply all these terms by r, I would have a sub 1 times r, a sub 1 r squared, a sub 1 r cubed, plus this would become a sub 1 r to the n. Again, boxing that in because I'm going to use it. Thinking of this as a system, subtracting the two, you'd have s sub n minus r s sub n. Okay, and so if I subtract them, a sub 1, well, there isn't just a plain old a sub 1 here. So I'd have a sub 1. But then I have a sub 1r minus a sub 1r. So those guys actually cross out. A sub 1r squared minus a sub 1r squared. Those cross out. And there's an a sub 1r cubed up here, which would cross out with this one. And your a sub 1r to the power of n minus 1, that would be right here. So those would cross out. But up here, in the regular old s sub n equation, you don't have just an a sub 1 r to the n. So really, you end up with a, right here, negative a sub 1 r to the n. So everything cancels out except the first term in s sub n and the last term in r s sub n. So that's what happened. That's where this came from. I can factor an s sub n out on the left and an a sub 1 on the right. Again, we're trying to show the summation, so I'm trying to isolate s sub n. I would divide both sides by the quantity 1 minus r. And this ends up being your equation for the summation of a finite geometric sequence. Again, r couldn't be 1 because you would get 0 in the denominator. So how do we take this and apply it to a question? So if you had one like this, number 5, evaluate the summation from n equals 1 to 20 of 2 times 0.1 to the n. So you do need to be careful here. A lot of mistakes that people make is that you actually have to calculate most of the time what your a sub 1 is. Okay, so again, it's not just 2 because look at the form that it's written here. So work that I need to do, I need to figure out what is a sub 1. All right, so following my equation, I know that a sub n is equal to a sub 1 times r to the power of n minus 1. Does that really help me in this case? Nope. I'm actually listening to what my son is doing while he should be napping, and that's why I'm not focusing at the moment. So no, what I just said is not going to help me. Can't wait to see where this is going to go. Anyways, start again. I need to take 1 and put it in for n into this equation. So expression. So I have 2 times 0.1 to the first. So I'm going to have a sub 1, which is just 0.2. So there's that. Okay, so to be able to use this equation here, I just found my a sub 1, which was 0.2. I'm going to, again, I'm following this up here. 1 minus, your r in this case is 0.1. And again, it says to the n, my n, there's 20 here. Okay, and I'm going to divide by 1 minus my r, which is 0.1. So if you do all your fancy footwork arithmetic, you're going to end up with 2/9. I will leave that to you. I'm not going to bore you with the arithmetic there, but there is that. Okay, only one more little note and then example. Let's see if I can get through it. Yesterday I couldn't. All right, last thing, geometric series. So if the absolute value of r, your common ratio, is less than 1, then think about it. As r to the n, here's my son again. Okay, let me say that again. Then as n gets bigger, as n approaches infinity, r to the n is going to get closer and closer to 0. Why? Because you're really looking at a proper fraction there, so, when the absolute value of r is less than 1. So as n is getting really big, if you keep raising r to some exponent, that exponent's going to make that fraction smaller and smaller and smaller, making r to the n closer to 0. You're like, why do I care about that? Well, because it has to do with the next topic. So taking that equation we just used previously for our summation, right? We just said that as n gets really big, r to the n is going to approach 0. Do you remember this notation that we used way back in like the first couple weeks of the class? Yeah, I do. Don't worry, you don't have to write it in terms of limits or anything if you're thinking that's coming. So all I did here was take r to the n. Again, we said as n gets really big, r to the n is approaching 0. So we're saying it's approaching. I'm putting 0 in for r to the n. Now this is just, you're just simplifying here. So you get a sub 1 over 1 minus r as n approaches infinity. So this is what we're going to use as n is getting really big. Think about it, if the absolute value of r was greater than 1, your series will not have a sum. So don't be like, where's the other equation? So what you're using to take this little conversation that we just had and to sum it up, the sum of an infinite geometric series, okay, when we're going from 1 to infinity, and it's a sub 1 times r to the n minus 1, like we just showed you up here. It's a sub 1 over 1 minus r. So this is kind of like a mini proof discussion as to where this is coming from. All right, so you got to pay attention if it is infinite or not, the difference between 5 and 6. So here we go, number 6. Come on, last one, I promise. If we ask you to evaluate from n equals 1 to infinity, of 2 times 0.4 to the n minus 1. So this fits the equation, if you'd like to call it that, the expression that's up here. So I can just jump right into this here. So in this case, your a sub 1, or if you want me to prove it to you and actually do out what a sub 1 would be in this case, right? I mean, a sub 1 is going to be 2 times 0.4 to the 0, because it's 1 minus 1, which is going to be 2. But again, because it fits that mold, your a sub 1 is 2, which was a little different than the setup in 5. So we have 2 divided by, what does it say, 1 minus r, and your r in this case is 0.4. Again, I would like you to leave it, I know you have a decimal in the denominator, but we want to try to leave these as fractions. You will get 10 thirds. And that's it, guys. Have a nice weekend.